In this example, you are going to calculate the standard enthalpy of reaction of ethane, a component of natural gas, by using these given enthalpy of formation values. Okay, so in this question, you already have this chemical equation, okay, but they are not balanced yet. And we also have enthalpy of formation for each of these substances. So we have enthalpy formation of carbon dioxide, of liquid water, and also for this one. So now, in this question, the main soalan is you are going to find the standard enthalpy of reaction, meaning that you are going to find enthalpy for this whole reaction. So, what you can do with the information given in the soalan is, so first of all, you have to check for the chemical equation. So before you start doing any calculation, please make sure this is balanced. Okay, so you must make sure the equation is fully balanced. So in this chemical equation, we can have 2 for carbon dioxide, 3 for water, and 7/2 for oxygen. Okay, so since we have enthalpy, so since we have enthalpy of formation values, okay, of these substances in this chemical equation, so in order to find enthalpy of reaction, so hence you can use summation values. Okay, summation formula. So, delta H reaction equals to summation enthalpy formation of product minus summation enthalpy formation of reactant. Okay, so this is our main question. We are going to find enthalpy of reaction. Okay, standard enthalpy of reaction. So what we have in the products part, so we have this water and carbon dioxide. Okay, and you may refer from these 2 given values. So these are enthalpy formation values for water and carbon dioxide, okay, in kilojoule per mole. So what does it mean by enthalpy formation carbon dioxide equals to negative 393.5 kilojoule per mole? So what does it mean by this value? Okay, it means that when you expand these values into thermochemical equation, okay, we will have carbon solid plus oxygen gas to form carbon dioxide gas. And if you still remember, according to the definition of enthalpy of formation, it refers to the heat change when 1 mole of product is formed from the elements. Okay, so these 2 are the elements that forming carbon dioxide. Alright, so make sure this equation is balanced. So meaning that for this kind of formation, this reaction release 393.5 kilojoule per mole. Meaning that in order to form 1 mole of carbon dioxide, this reaction release 393.5 kilojoule of energy. So when you are writing the thermochemical equation, make sure you have a balanced chemical equation, and you have to make sure where to put the 1 mole according to the definition, and the enthalpy over here must be in kilojoule. Why? Because this value is already referring to 1 mole of this product formed from this reaction. Okay, so this is just for your general knowledge, okay, on how to convert this abbreviation into this thermochemical equation, okay, into the full thermochemical equation. So now, in this kind of example, we will simply using these values into the summation formula. Okay, you don't have to expand these values into its thermochemical equation. Okay, you don't have to. Okay, we will simply use this value into this summation formula. Okay, so for the products, we have carbon dioxide and water with the respective stoichiometric coefficient. So please include this stoichiometry into our formula as well. So we will have 2 mole of carbon dioxide, and the values is negative 393.5 kilojoule per mole, meaning that over 1 mole. Okay, so plus with the other product, which is water. So we have 3 mole of water. Okay, kilojoule per 1 mole as well. Okay, so we have finished with our products. So now we are going to minus with the reactants. So in this reactants, we only have the value enthalpy formation for this substance. Alright, and the soalan does not give you any information regarding oxygen. Why? Because oxygen exists naturally in nature, so the value enthalpy formation for oxygen will be 0. Okay, so please bear in mind, anything that naturally exists in nature, the enthalpy formation values is 0. Okay, so we're going to minus these two with this one reactant only. So we have 1 mole of ethane, and the value is negative 84.7 kilojoule over 1 mole as well. Okay, so now you just have to cancel the values and you will get your final answer. Okay, so you can try doing the calculation and you can check the answer later on. In this example, you are going to find enthalpy of formation values from enthalpy of reaction. So let's have a look at this kind of soalan. So calculate the enthalpy of formation of butane from the given information as below. So we have this given chemical equation with the respective enthalpy of reaction and also enthalpy formation values for these two substances. So as you compare with the previous example, in the previous example, you are needed to find enthalpy of reaction from the given enthalpy formation values. Alright, so in the previous soalan, okay, you have every information for enthalpy of formation for all substances, and hence from these given values, you are able to find enthalpy of the reaction. But in this soalan, okay, in this question, we already have the enthalpy formation, and the enthalpy of reaction values, and you also have the enthalpy formation for some of the substances. So in this case, we just have enthalpy formation of water and carbon dioxide. Alright, so we already have this value and this enthalpy formation values. Okay, so soalan did not give enthalpy formation for oxygen. So please bear in mind, since oxygen is naturally exists in water, so enthalpy formation values for oxygen will be 0. So meaning that in this kind of practice, in this kind of example, we have enthalpy of reaction value and we have enthalpy formation for these two substances, and this is our unknown. Okay, so we need to find enthalpy formation of this butane. Okay, so is that possible to find enthalpy of formation? Yes, it is possible. If we already have enthalpy of reaction value and enthalpy formation for some of the substances, so you will be able to find enthalpy formation for the unknown substances. So what is the method? So the answer is by using summation formula as well. Okay, now, so according to the formula, enthalpy reaction, standard enthalpy reaction equals to summation standard enthalpy formation of product minus summation standard enthalpy formation of reactant. So again, in this formula, I did use the standard condition. Why? Because in the soalan, okay, it gives you in standard condition. Okay, so let's insert the values. So we have negative 2877 kilojoule in this enthalpy of reaction. And for the product we have, okay, so before you do this summation calculation, please make sure your equation is balanced. Okay, so in order to balance this equation, so we need to have 4 carbon dioxide and 5 for water, okay, and 13/2 for oxygen. Okay, so let's just insert the values. Carbon dioxide is negative 393.5 kilojoule per mole, meaning that divide with 1 mole. So plus with other product, which is water. Okay, so water in gaseous form will have different enthalpy of formation values. So gaseous water, the enthalpy will be negative 241.8 kilojoule per mole, again over 1 mole. Okay, and minus with, this is 1 mole, so minus with 1 mole of our unknown, C4H10. Okay, so we will cancel the mole. Okay, now, so here you will have, after you do all the cancellation and after you adding or subtract all the values, so you will get the value of delta H naught formation of this butane will be 94 kilojoule. Okay, so according to this abbreviation, enthalpy of formation of butane, it means that when you expand this abbreviation into a full chemical equation, the enthalpy formation of butane refers to 1 mole of butane formed from its element. Okay, so what elements that can form the butane? So we have carbon solid and hydrogen gas. Okay, so we have 4 carbon over here and 5 for hydrogen gas. Okay, so from this equation, when 4 mole of carbon react with 5 hydrogen gas, so hence we will get C4H10. Okay, and the phase is in gaseous form as well. So the enthalpy of this formation of this reaction is actually 94 kilojoule. Okay, and this 94 kilojoule is actually values that represent 1 mole of butane formed from this reaction. So from this answer, seems you have got delta H formation for C4H10 is 94 kilojoule. Okay, so seems formation of butane refers to 1 mole of butane form. So in order to get the final jawapan, so you have to divide your answer with 1 mole, so that you will get your jawapan in kilojoule per mole. Okay, so this will be your final jawapan.